Hi, I'm Gwangtak from Seoul National University. In this video, I'll present the work I2-SLAM, Inverting Imaging Process for Robust Photorealistic Dense SLAM, which was done jointly with Changwoon Choi, Hyeongjun, Sang-min Kim, and Young-min Kim. To briefly summarize, our method takes casually captured videos and reconstructs photorealistic and sharp HDR maps by inverting imaging process. Recent dense SLAM methods use neural radiance fields or 3D Gaussian splitting for map representation, and they reconstruct photorealistic, dense, detailed maps with camera poses. However, unlike the remarkable results on synthetic data, they often produce inaccurate results on real-world data. There are two main challenges in real-world data. First, motion blur frequently occurs due to camera movement during the exposure time. Second, blurring appearances arise as a result of auto-exposure and white balancing. These image degradations are critical bottlenecks for the accuracy of map reconstruction and pose estimation. To address these problems, I2-SLAM simulates motion blur and tone mapping, compares the results with input frames, and optimizes HDR map and camera poses. Our image formation process simulates motion blur by optimizing the camera trajectory during the exposure time. From the HDR radiance field, multiple sharp HDR images are rendered from multiple poses along the camera trajectory. By averaging multiple sharp HDR images, we obtain a blurry HDR image. Next, we simulate the tone mapping process. We optimize explicit variables, namely exposure time, white balance, and camera response function. The blurry HDR image is eventually converted into a blurry LDR image that simulates the image degradation in the input frame. We apply a rendering loss between the simulated image and the input frame, and optimize per frame camera trajectory and tone mapping variables. Additionally, we propose a trajectory loss that regularizes the per frame camera trajectory during the exposure time. Our trajectory regularization is designed based on two key insights. First, the per frame camera trajectory should align with the global trajectory from previous localization results. Second, the camera has a long trajectory when it moves fast or has long exposure time. Since we optimize exposure time in the tone mapping simulation, we additionally optimize the global scale parameter which describes the relationship between exposure time and the size of the trajectory. I2-SLAM is a generic method that can be combined with any existing photorealistic dense SLAM methods regardless of input modality or web representation type. We demonstrated the effectiveness of our method on two state-of-the-art approaches. In the RGBD SLAM experiments conducted on scanned dataset, artifacts caused by blurring appearances were removed through the tone mapping process, and the effects of motion blur were minimized. The mapping performance has improved quantitatively, along with better accuracy in camera pose estimation. Similar performance improvements were observed in RGB SLAM experiments conducted on TUM dataset. We observed the fine textures which had been lost due to motion blur were accurately restored in the mapping process. Quantitative metrics for both mapping and camera tracking showed significant improvements. Lastly, we analyzed the runtime and efficiency of our method across multiple models with varying number of iterations. Although our method increases the runtime per iteration, it reduces the number of iterations required for optimization. As a result, our method demonstrates better mapping and tracking performance when using a similar runtime. In conclusion, I2-SLAM reconstructs sharp HDR maps from casually captured inputs by inverting imaging process, and it can be incorporated into existing SLAM methods using neural radiance fields or 3D Gaussian splitting. Thank you for listening.